So this talk is called smbcmp, a network capture diff tool for SMB traffic. So who am I? My name is Aurelien Aptel. I work at SUSE Linux in Germany. I work in the Samba team, where I mostly work on the SMB kernel client, which is also called sifs.ko. I know the name is a bit old, but that's what we use. So I work there's a user space tools that comes with the kernel module called sifsutils. And I also work on other SMB related things like Wireshark and Pike. So what is this about? So at SUSE I mostly have to work on kernel bugs related to sifs.ko. So over the years I've developed and found many ways to facilitate the debugging work I do to find bugs. And so I will show some of the features I've worked on, some of the methods I use to debug. And so this is mostly useful for developers, but also for administrators and other people who have to diagnose network issues. So debugging is hard. There is no one method to solve every bug issues you find. Some approaches work better than others for certain bugs, and those same approaches won't work for other bugs. So yeah, it's overall pretty hard. So the SMB bugs can be either in the client, they can be in the server, sometimes it's in both, sometimes the specification says something and then it's not what actually happens, and sometimes the behavior is not specified at all, so there's a lot of gray and blurry areas we have to think about. So with that in mind, your goal is usually to isolate possible failures, because there are so many things that can fail. So you try to just find a subset of code you have to search into to limit the amount of time you waste looking around. So the first one is pretty obvious for developers. So bisection. So the idea is pretty simple. You find one good commit, and then so at a point in time where your software was working properly, and then a point in time where it doesn't, and you try to find a spot in between where the bug was introduced. And so by picking a commit in the middle, and by trying this one, if this one is good, it becomes your new bound, and so it effectively cuts your search space in two every time you do this, and so you can go through a lot of commits pretty fast. So like 130,000 commits, you can just bisect in only 17 steps. So it's very good at isolating code. And you can automate this with a script. Git has support for this. So it doesn't just apply to Git. Obviously, any source control version would have something. You can do it manually. So of course, you can read code. You want to avoid doing this because sometimes the code is just too much. So you will lose a lot of time. So it's a good idea to reread the spec one more time in the area you're working in to make sure you understand what's supposed to happen. You find the corresponding code path in your client or server. You look for bug, typos, run logic, etc., and you repeat until you get it, which can take a lot of time. So it's not ideal. Another thing I often use is using different implementations. So you have the Windows server and clients. You have Samba, which also has a client and a server. So the Linux kernel has the sifs.ko, which is one other client. So Samba also comes with a test framework, which you can write little small clients that only do one thing you want to reproduce, which can be useful. and gives you control over the fields of each header, so you can really make it do what you want. There's another one I like to use called Pike. It's a Python library where very easy to use and extend. And when I want to experiment, it's pretty good. We use this to test some of the POSIX extensions we worked on with Steve and Jeremy. And Microsoft also has a large testing framework, but yeah, I still haven't dug into it. I'm sure there's some stuff that can be used from there. So you can use a debugger. This is if you're a programmer, usually this is where you start. But for network protocols, it's hard because every time you do a breakpoint, you might introduce timeouts, and so you end up debugging something different than what you're trying to debug. Also, Samba has, so every time you make a session, an SMB session, Samba forks the process and sets basically for each session you have a new process, and so when you debug this, you have to tell your debugger to follow the child, or not, depending on what you want to debug, but usually it's the child. So these are commands, GDB commands, if you use GDB, that you can use to make it easier. Now for the kernel, so if you use QEMU to run your if you test your kernel by using a virtual machine via QEMU, there's a flag that creates a GDB server that you can connect to and debug like a regular program and step into it and break and all those things. But again, you still have the timeouts, and yeah, it's annoying. But I've put the command there. So you start QEMU with -s, and then you tell GDB to connect to this server that was created, and you point it to your kernel binary. And this is the port. I think it's over TCP. The kernel comes with some Python helper functions that you can load into GDB, and they have functions to list superblocks, to walk down linked lists, and all those things. It's pretty useful. But unfortunately, the kernel cannot be compiled without optimization. So on top of all those problems, in the debugger, you often run into weird things happening. So the compiler will reorder your instructions, and so when you step, sometimes your code jumps into random places in the function, which is hard to think about sometimes. Some values you cannot print them. The debugger prints optimized out, so the value has been. You have to look in the stack, or yeah, it's not easy. Sometimes the function calls get inlined. So yeah, again, you end up jumping from one place to the other. It's hard to follow. And you cannot compile without optimization because the kernel relies on them. It's a long and complex issue, but yeah, for now there's no way to compile without optimization. So you also have logs. So Samba. So if you're debugging your client, you can try connecting to Samba and setting the config to make it as verbose as possible. It spits out a lot of log. So I have I wrote an Emacs mode, which allows you to open those logs, and they're easier to navigate into. It adds color, and you can filter by things. And so I have a little demo I can show you. Is this big enough? Yeah. So the size makes it a bit hard to read, but basically this is a Samba log file. You have a little header with the source location here, which is highlighted, and the messages of each log call is here in white. So yeah, there are commands to jump from messages to messages. You can compress or expand messages if they're getting too annoying to see. You can highlight special, so let's say you're trying to track an IP, so of your client that just connected. So let's say this one. You can add highlights of this IP. And let's say you want to track this key ID as well. Okay, I guess I mistyped. But yeah, you can have multiple words highlighted with different colors, and it makes it easier to track things. But it's in Emacs, so yeah, it's a bit of a. So not everyone uses Emacs. Anyway. So to make the kernel more verbose, you can also use those things. It will make the SIFS module print a lot of things, which really helps out when debugging things. The kernel also comes with ftrace. It's a thing to it's like strace, but a lot more powerful. So strace tracks syscalls on Linux. You can type strace a command, and it will print out all the system calls this command is making. And so ftrace does the same thing, but you can look deeper into the kernel stack where each syscall what each syscall ends up calling in the kernel. And you can do this system-wide, not just for one process. So in Windows, it's similar to, I guess, making etw events trace logs and opening them in Message Analyzer or Procmon, something like that, if you're familiar with those things. So for example, I had one bug where okay, so yeah, this is just one example of the ftrace command. So this command would call this mount program to mount your share. And by saying you want all events and you want to trace all the function calls, so you do this, it will run your mount command, and then you type trace command report, and this is what it will print. So you can see each function name in the kernel that gets called, and you can follow the whole timeline and what gets called by what, and it's extremely useful. You even have timing information, so you can do some performances analysis from this. You can do system-wide recording. You don't have to limit it yourself to one process. So I had a bug this time where a customer was saying something was mounting his share, but he didn't know what. And so by doing this, I just say record all syscall of ID 165, which is the mount syscall. And surely enough, if you look at the logs afterwards, you see that this process with this PID ended up calling this syscall. And so we knew something was calling mount.sys, and from there we could find out what, and etc. So there is a, I'm using a trace-cmd in those examples, which is a helper program, but you can also use directly the file system-like API in the kernel. So you don't need an external program. If your customer doesn't want to install anything, you can just have this little script that would, it's doing the exact same thing I did earlier, but manually. So yeah, this is all documented, but yeah. This is just a simple example. So another thing I use often is when you have a, sorry, yeah?
Just before you go on to stack traces, in the NFS client and server, we've been adding the trace subsystem specifically for NFS.
Okay.
Wondering if you have any thoughts about adding a similar subsystem for the SIFS client.
So you mean ftrace trace point, or?
Yeah, we're adding specific trace points
okay.
in there, replacing the debugging print case with trace points.
So we're currently doing this slowly, converting, I think, as well.
Okay.
We have maybe 50 or so trace points. 72.
Last year we were 20.
Okay.
XFS guys bugged this a year and a half ago at the kernel file system saying, why aren't you using this? So we added 52 last year.
Okay. So yeah.
Slow progress. XFS is at 550.
Yeah, there's still a way to go.
Yeah, exactly.
Can you sort of repeat some of that for the recording? Just summarize it.
So the Linux CIFS kernel module added ftrace trace points because they're more helpful than regular printfs, let's say, and like NFS did apparently. So we're adding more and more. All right. So next thing I use often is so sometimes we have mutexes in the kernel, and so if one process does something and another process does the same thing, and they both acquire the mutex, sometimes you end up with a situation where there's a deadlock and both processes are somehow stuck waiting for each other. And so you can see where each process call stack in the kernel is. So there's a in the proc file system, you can print, so for this process, for example, the PID is 22859, and so you do cat to print the file, so cat the PID stack, and so those stacks are read, so it's a stack trace, you read from the bottom to the top. So it did a stat call, so you can see it enter the stat call at the bottom, and eventually rose up to deeper in the SMB module, and it's the last thing it called and seems to be stuck in is open root. And in the other process, which is stuck, you see it has a similar call. It did a stat, it did open root, and then it kept on going, and then it's stuck here. And it turned out both those functions were taking the same lock, and this guy was waiting for the lock this one took. So yeah, we found out the deadlock this way. So it's very useful. And finally, you have network captures, which is like a wire log. You just capture every packet that is sent on the wire, and you look at it and for analysis later on. So there's a good software that does this, Wireshark. I'm guessing most of you are familiar with this software. You can filter by protocol types. This is the filter I usually use, so SMB1, SMB2, and above, so 3 and 311, DNS, and Kerberos. So even though it says Kerberos 4, it actually does 5 as well. So yeah. So you have your capture. Side note: Wireshark has decryption support now, so you can capture your Azure traffic, and if you have bugs and stuff, you can, given you have the keys and everything available, you can give those to Wireshark, and it will show you your traffic decrypted. Sorry. So what you need to give to Wireshark is your session ID and session key. And to do this, so in Samba there is a debug option which I added recently, debug encryption. So this works both for the client and the server. If you put this in smbcmp, it will be used by your client, by a semi-client, and by the server, and it will print in the log the keys and all the things you need to decrypt. I will show this later on. If you just need the client, you can pass it on the command line. Yeah. And for the kernel, there's a debug debug config option. So you need to recompile the kernel for now, but it will print out in your DMSG, so in the kernel log, the keys. And in the next coming kernel, there's a new ioctl, so a system call you can make from user space. So you point it to a CIFS mount or SMB mount, and it will dump the keys. You need to be root, obviously. So yeah. So the last one is more practical because you don't have to recompile the kernel. All right. So you have. So this is an example of calling SMB client with this debug option. So you pass this option. This is what it will look like. It prints all those things. So the session ID is this thing in yellow, and then you have session key in green. And you just stick those two things to Wireshark when you call it. So you can do this through the command line via this OAT flag, blah, blah. Or you can also do it through the preferences of Wireshark. So you go to edit or something like that, preference, you go to protocol, you go down to SMB2. There should be this little secret session keys for decryption, and then you have this table. You can add the same things I showed earlier. For the kernel, it looks like this. If you have enabled this debug option, every time you mount, you run dmsg afterwards, and you grep for sieves, and it will print those things. You just have to stick them into Wireshark, and yeah, you're good. All right. So some other new stuff that got in Wireshark recently: better parsing of compounded responses. Some support for parsing NFS reparse tags back, and some very new changes from SMB 3.1.1. So the negotiate context ID and the decompression of all compression types. So as far as I know, those 3 ones. So there's nothing special to do. You just open your trace, and it should show you the payload decompressed. I have a trace here I can show you. Wait. All right. So this trace has contains 3 read responses compressed with 3 different compress types, and it shows up here. Yeah. So yeah. Here you see the compression algorithm. So yeah, this one, and yeah, that's it. So, to debug, you can make a trace of a working case and a non-working case and compare them side by side. But in Wireshark, it's annoying. You have to open 2 windows and click and expand all the little thingies, and so yeah, and you have to look hard at both, and it's annoying. Sometimes there's a lot of fields you have to expand. And so you do this over and over, and it's annoying. You click, and voila. So yeah. So it would be great if you could automate this comparison thing. And so Wireshark doesn't really have a programmatic interface, no APIs you can use. But there is a text version of it called tshark that comes with it. It dumps everything in plain text or XML or JSON. There's also a daemon thing, but this is not documented, so I haven't really tried playing with it. So tshark, you pass your trace, you pass your filters, and this is how it looks like. It just prints the summaries you would usually see in the GUI. If you add the -V, it dumps the detailed view. So combining those 2 things, you can make a program that basically dumps all packet and do a diff of the detailed view. So yeah, so I wrote a Python script. So initially I had this Emacs prototype, but it's not good. I made a Python script afterwards. It calls tshark in the background. There are 2 modes. You can either view a single trace, sort of like Wireshark, normal Wireshark, or you can have there's a diff mode where you read 2 traces and you show them side by side, and you can diff the detailed output. Yeah.
I'm sorry, just one moment back on the tshark.
Mm-hmm.
So I've just been experimenting with that recently, and there's a table I really like in the regular Wireshark UI. That's the SRT table, where you can see for SMB, you can see the different response times.
Right.
I couldn't seem to get that working with the tshark. Get it from
I've never tried, I think.
What's that?
I don't think I've tried before, so.
Yeah, I can show you that.
Yeah, sure. Yeah, diff trace summary. Yeah, okay. So yeah, it's available on this GitHub thingy. There's packages for Linux, most OSs, and I've even ported it to Windows. So there's a simple zip you extract, and there's nothing required. You just open and run the exe, and it should work. So well, during the summer we had the Google Summer of Code project thing. So the smbcmp as part of Samba was accepted into GSOC. So we had a student from Cameroon, Paul Maro Rufus, who worked on improving smbcmp. So he initially worked on the Wireshark XML output to make the diff more precise, because currently we're using the text output. We were using a text output. And using the XML output allows for more precise diffs. And you could also, we are currently working in making some fields. Yeah.
It's basically a diff of two traces, correct?
Yeah.
Does it use kind of different protocols? Like, does it need to be only SMB?
So theoretically, it could work with any protocol, but since I'm mostly working with SMB, I made it SMB specific. But I think it could be generalized with any protocol for sure. Yeah. So yeah, so this summer we added a couple of things. So he worked on those things. He added the new GUI. So initially it was text only, but he worked on a WX widget GUI. So that's cool. And the ability to search in the summary. So I'll do a quick demo. I have a couple of things. So the text version, SMB3. Oh. That's not what I wanted to do. All right. So this is how it looks like. So you see there are two captures loaded on each side by side. You see the summaries on the top. And in the bottom pane, you have the diff of the detailed view. So the protocol request is the exact same on both sides, so there's nothing to show. But as soon as you get to the response already, you can see some differences. So the time to it takes for the server to reply obviously is going to be slightly different, but this can be ignored. The system time returned by the system is different as well, but yeah. So now it makes all the differences very easy to spot, and really it helps a lot. You don't have to think about which field could have changed. You can just diff everything and ignore what you think is ignorable and consider only what is worth considering. And so, for example, this one, looking around, I could see there is some difference in authentication, but I mean, session is properly opened in both sides. I can see one by one that each packet seems to be similar. Signature is different because that's how sign-in works. So nothing really jumps out of the ordinary. And so from this, I knew the error was in the logic of the client more than what we sent on the wire. So I didn't have to look more into that. And that was a very quick thing to do. Yeah. So it makes sense to only compare packets of the same type. So sometimes the traces are slightly different, and so you will have slightly more packets on this side than the other. And so you can change the cursor position, like you can desynchronize them, the cursor on each side, and still move together. Sometimes this is useful. So this is the text version. We have a GUI now. Let me just. So this is the exact same thing, but in the GUI. So this one is usable from Windows. You don't have to install Linux for this. So yeah, same thing. You can even try out the XML mode here. So in Engine, you can go PDML instead of difflib. And this. Okay. No. Okay, maybe not. So it's still experimental, this mode. All right. What else can I show you? I can compare compressed traces. Decrypt. So in this case, both traces are using a seal or sealed, so they're compressed using different keys. But you can still decrypt and compare them, and compare the payload once it's decrypted. So it's very useful. So at the moment there is none. In the GUI version, in the development version of the GUI, there is a search bar. You can search for specific summaries and things like that. But yeah, it's not released yet. Yep. Okay. So yeah, it works on Windows now. So this is a screenshot of it running on Windows. Again, there's no dependency. You just get the zip, you extract it, and you run. It's very easy. So you can even run the command line version within the console if you're into that. It works. Yep, that's pretty much it. So some of the things we're looking at for future work is deeper analysis of for the diff. So you can say, and add ignore rules. So you can say, for example, ignore time differences if they're above a certain amount. So if let's say a packet, you could add a rule that says if a packet takes over 3 seconds to get a reply, make those differences appear, otherwise ignore them. You could also say ignore differences in this particular field unless this field has this value. If you have very long and very large diff, it's kind of useful, I think. And overall UI improvements, like searching and all those things, I think could be improved. And one thing I would like to play with as well is, so QEMU has supposedly a record and replay mode where you can run your kernel and record all the input and it has, and then replay it. So for network stuff and anything that is kind of unpredictable, it's very useful to reproduce specific bugs. But I don't think, I think it was a Google Summer of Code project to implement this, and no one has really picked it up on it afterwards, and I couldn't get it to work. So yeah, something to improve, I think. And that is it. Any other questions? Yep.
So if you have like two traces from significantly different server, right? Like all the same activity, like open a file, read, write, but a different server.
Mm-hmm.
One server is SMB3, the other one is SMB1. Artificial example.
Mm-hmm. As long as Wireshark is able to analyze and dissect those traces, you can still diff them. And so if you compare SMB 1 and 2, it's going to be not very useful because pretty much every line is going to be different. There's not much common things between those protocols. But for a different server of the same, but still using the same protocol, I think it's still useful. One thing you will get is probably one trace will have more packets than the other because the client is doing, or the server is doing more stuff. But you can, as I showed, you can desynchronize the cursor and to make it match whatever you want. You can even open twice the same trace and jump to a different packet later in the trace and compare those things, if you want to do that.
Can you talk a little bit about some of the journeys you took discovering which fields to ignore? That seems like the most interesting part.
Sure.
How do you figure out which fields are you going to ignore when you're doing a diff?
So it depends on the issue. If it's let's say. So the question is, how do I know which field I should ignore when I'm working on a diff?
Well,
And
do you have a general list of those, or do you have to adjust that list for every problem you work on?
well, yeah, you have to adjust for every problem, but there's definitely some common things. So if you don't care about authentication, you know, you want to debug something later on with the I/O stuff, and you don't care about user stuff, you can just ignore all the differences in you know, crypto or anything like that at the session setup stage. Otherwise, time differences, again, as I said earlier, if the server takes 0.005 or 0.006 millisecond to reply, you don't really care about those things. I mean, signing, the signature will be different, of course, most of the time. Unless you're debugging signing, it doesn't really make sense to look into it, I think. Yeah, it's down to the protocol afterwards. I don't know much about NFS. I know more about SMB, so I can't really talk for your case, but yeah. Steve?
So presumably you ignore, so if you had two traces and the UID differ in a frame.
Mm-hmm.
Sorry, the session ID, excuse me. The session ID, you ignore that, right?
It will show up as different, but yeah, we could, if we get to implement those rules of ignoring certain things, and
So I think
we could make.
the example that would be common would be, I mean, I for argument's sake, last night, right? I shouldn't code at night. But last night, I had one working, one failing after a patch, and I wanted to compare them. So I brought up Wireshark, and it turned out that created options were set as -1 because they had two fields backwards. So the only difference was create options or something, and in one case the server was returning an error because they looked identical here, but on this path you had a field that was split.
Mm-hmm.
I don't care about the session ID. I don't care about the multiplex ID. I don't care about the persistent file handle ID. But everything else I care about.
Right.
So you figure that 3 or 4 of those rules would be common like that.
Mm-hmm.
Because they would always change
Yep.
between two things.
Yeah, exactly. Yeah.
Okay, so those aren't defaulted in these rules, but we could set them up.
Yeah, yeah. So with the XML output parsing we implemented this summer, we could definitely say this field should be always ignored. And so we actually have some experimental code. Once you're highlighting a field, you can press I to say don't highlight this field anymore for the rest of the session. And it's kind of working, but I would like to make it more easier to use. So yeah.
Would it be possible to see an example of how you set that up with your demo?
I'll try.
While you're setting that up, are you going to be available during the open reception tonight to show people demos and talk to people about this?
Sure, yeah.
So everybody knows at 5:30 downstairs in the bug pass room right at the bottom of the escalator, open reception, and you go in and find Aurelien and ask for a demo and set up a problem and take your time to do it.
Oh, okay, so I'm not sure what's going on right now. It should work, but it's not. So yeah, sorry. Later on, we can look into it. Yep.
Just kind of a dumb question. For like the UI version of it, is there some architectural reason that Wireshark doesn't have a sort of ability like this?
I don't know if they've ever tried to implement it. I haven't got in touch with Wireshark people about this yet. I'm sure they would find it interesting.
I imagine that for every protocol, you would need to come up with that list of these are likely to be different fields fields,
Mm-hmm.
kind of that way. But having a tunable, making that something you can configure would be a very interesting thing to be able to do.
So as I said, normally if this, I don't know why it's not working, but wait, let me try something.
So you can do that, is what you're saying.
You can press a key that makes the field currently highlighted as ignored. And so for the rest of the analysis, it will not show up as different.
Can you undo the fields?
Yeah, you just press again to toggle the ignore
When
state.
fields are like signature, can you undo?
Yeah, exactly. Yeah. So you would go to signature, press I, and poop, it will not show up as different on the rest of the.
It came in late, actually.
Yeah, it's fine. I'll try the older version. I don't know. Yeah. Yep. Yeah, I don't know. I'll look afterwards. Sorry. Yep.
I was thinking about typical things that are common, and you may have talked about this earlier, but one of the common things I have is I've got a Wireshark trace. Maybe I'm looking at GCM versus CCM.
Mm-hmm.
And what I want to do is I want to look at what's the average read response time or something for the server.
So for this, you can use the SRT thing this other person mentioned earlier. In Wireshark, there's a mode that says for each SMB2 command, you can look up the average response time, min, max, and all those things. And I think it's SRT, yeah. But
So some of this stuff, there's a wiki page you've got for some of this?
so for decryption, for how to use decryption, there's a web page. Wait, I think it.
Yeah, it was pretty good, I thought, because it had the screenshots of what was put in.
Yeah, there. So on the Samba wiki.
Yeah, and I thought that was actually really good.
Oh.
But the other example was like what you just said, having that, and there's a troubleshooting page for Samba and a troubleshooting page for the kernel sys client. That example you gave, I want to tell how the average read response time or query info or whatever.
Mm-hmm.
Typically it's open, that's the weird one that varies a lot, right? Or closed even, closed varies a lot. Being able to like type a one-line command, we ought to have in our wiki for debugging, because everybody's going to forget this after the talk and then want to see it again.
Yeah, I realize it. Yeah, look on the Samba wiki. There should be some info about it.
Similar question. So the big comparison you said like the time taken, is that the actual response time or is it just only the offset from the previous request?
I think it's the response time as given by Wireshark from the previous request, I guess. So the round trip, yeah.
It correctly accounts for the asynchronous responses as well.
For the?
Will it correctly accounts the asynchronous responses as well?
You have to check. I'm not sure. Yeah.
One other example. So Ronnie had done a set of changes, right? Ronnie had done compounding changes. So one of the things that would be super useful, and I think if you can do the time thing with this tool, then maybe do this as well. You've got two different kernel versions. You run some XFS test, whatever.
Mm-hmm.
With Ronnie's patches for compounding without, with this performance option without. In one case, I sent 1,000 opens, 10,000 query infos, 1,000 closes. The other way, it's 500 opens,
Mm-hmm.
1,500. If there's a quick way to get a
Statistics of.
with this patch, I had 500 of these. With this other patch, I had 1,000 of these.
Yeah, I think you can do all those things with just plain Wireshark. Wait, let's see if I can figure it out live on stage. I need a trace. So SRT is service response time. So you can do this with SMB2. It shows you the number of each command and the number of calls it happened, minimum, max, average.
Yeah, we should have a screenshot of this because everybody's going to forget it. This is so useful.
So there's this. You can even filter within SMB2 the ones you want to take into account. IO graph, I think.
Maybe to Steve's point, you could put some of the screenshots of some of this useful stuff in an appendix to your slides.
Yeah, I could.
And we'll be happy to post them.
That can be done, yeah, sure.
Because I know you don't have them in there yet.
So I think here we can say SMB2. Yeah. Yeah, no, this is Ronnie made a presentation about this, and he has slides with screenshots that details how to do this stuff. I have to look it up every time I do, but it's useful. You can basically see, you can graph the I/O throughput throughout the trace, and you can see where there was a hang or something like that, what took time in the trace, and you can move your mouse around and see which packet a point corresponds to, and it's very useful. I just don't know how to do it live, so sorry. Yep. Okay, well, thanks for coming.